going to talk about a geometric series. We're going to see the summation, the convergence, and what value the series is converging when it is converging. First, the notation. Because we're talking about a series means the summation of a sequence, of the terms of a sequence. We are talking about a geometric series, so that means that the terms are multiple of the first one. So here we have a sub 1, the next one would be a sub 1 times some number, the third one is a sub 1 r times that same number, so r squared, I sub 1 r cubed, etc. And so our common ratio is I sub 1 r divided by I sub 1 is just r, so our ratio is r. Now you can see this as a summation when the first term is k equals 0, or when the first term is k equals 1. That is, you can say that this number is k equals 1 or k equals 0. Now, here I have 4 terms. 1, 2, 3, 4. So how can I express just this summation of this geometric series? Would be a sub 1 times r, that is, we can increase the number of k, and so a sub 1 r to the k, so we would have the first one would be a sub 1 r to the 0 is just 1, the next one is a sub 1 r to the 1 is 1, a sub 1 r squared, etc. Now, if we want to end up at r equals 3, so that is when k is equal to 3. So here is from k equals 0 to k equals 3 of the sum of a sub 1 r times k. Now, notice that this number, when we're beginning from k equals 0, this number corresponds to the exponent of r of the last term, and is exactly one number less than the number of terms that we have. Here we have 4 terms, and here we put n minus 1. We are putting 3. Now, when we have a geometric series, we will not see it like this. We would see, for example, 1, 1 half, 1 fourth, 1 8, 1 16, etc. So if we want to figure out this number, the exponent of the r, here our ratio is 1 half. Here you can see that we have 5 terms, and the exponent of the r here of the 1 half is 4. So this one you will express it as the summation from k equals 0 to 4 of a is 1 in this case. That's our first term. So just 1 half to the k. Now, this one's when you begin with k equals 0. But what if I want to call this a sub 1, this first term, I want to call it k sub 1. So would be again k sub 1 of the summation from k equals 1 of a sub 1 r to the k minus 1, because the first term is a sub 1. So this one, if we do the formula, that is, let's plug k here, the first term is a sub 1 r to the 1 minus 1 is 0, whatever thing elevated to 0 except 0 to 0 is just 1. The next term is when k is equal to 2, I have r to the 2 minus 1 is just r, so I 1 r squared, etc. So here we would go to n, because in this example, when am I going to end up with I sub 1 r to the third power? This would be when I have n equals 4, because if k is equal to 4, this last term would be a sub 1 r to the 4 minus 1 will be 3. So when we are talking about a summation beginning from k equals 1, here we put the number of terms that we have. Now the number of terms that we have will be one more than the exponent of the r in the last term.